Okay, so with the last video, I left you with the following question. What happens to the energy in a capacitor if I increase the capacitance? So you're going to look at this, look at these equations up top, and you're going to realize that in one equation it looks like it's proportional to the capacitance, and the other one it's inversely proportional, right? So why? It depends on if it's connected to a battery, constant V, or disconnected, constant Q. So let's take a look. So let's give like a real concrete example. Let's increase the distance between the plates. Okay, so remember that the capacitance is epsilon not A over D. So think about what that's going to do to the capacitance. Hopefully you realize it will decrease it. Okay, so what happens to the energy? Let's look at these two different situations. Well, first let's throw those equations up there, remind ourselves. All right, if it's connected to a battery, that means that V is constant. So think about which one of these equations we might want to use. So if you look at the 1/2 QV, that's not very easy because it doesn't have the obvious C in it. So if we look at 1/2 CV squared or Q squared over 2C, if you look at Q squared over 2C, Q is also changing. And so that's not going to really help me. But V is staying constant, so I want the 1/2 CV squared guy because there's my V is constant. So if my capacitance decreases, then my potential energy, or my energy in the capacitor decreases. All right, if it's isolated, Q is constant, then we're going to want to use Q squared over 2C. Q stays the same, my capacitance goes down, and my energy goes up. Okay, so again, we have this seemingly contradictory thing. In one situation, my potential energy decreased, and the other one, my potential energy increased with decreased capacitance. So, excuse me, why? How? Like, what physics is going on here? Where did the energy go or come from? If the energy actually is decreasing or increasing, it had to come or go somewhere, right? So, think about what's happening. When you're connected to the battery, remember what a battery's job is. Battery's job is to keep the potential difference across the terminals constant. And the way that it does that is it sends charge or takes in charge to do that. So imagine you have increased the distance between the plates, which decreased the capacitance. That decrease of the capacitance, it means you will have less charge for the same potential difference. So the charge decreased. So where did that charge go? They went back to the battery. The charges went back to the battery and took some energy with them, right? So in order to keep V constant, Q decreases, and that energy lost went to the battery. So that's why the energy decreased. For the next situation, the energy increased. So we had to do work to increase the distance between the plates, right? By increasing the distance between the plates, we are annoying our charges. They like to be close together. We are moving them apart from each other. So we have to do positive work. It's like lifting a barbell up. I have to get it away from the earth, so I have to do positive work on it. So that positive work that I'm doing on those plates, that goes into the energy increase of the capacitor. Okay. Oh, and that's all she wrote.